Here we have a SAT math question. Okay, let's go with the information. X square negative 5x negative k equals to 0. In the equation above, for how many integers x is the number k negative? Okay, we have to find the number of integer values for x so that the number k is negative. Okay, now let me take the given equation as it is. That is x square negative 5x negative k equals to 0. Okay, now let me add k to both sides. When I do so, I am getting x square negative 5x. So here this negative k, positive k will cancel out. On the right side, I'm just getting k. And the question clearly says this number k is negative. That is, k is less than 0. When k is negative, then the stuff which is equal to k must also be negative. That is, this expression x square negative 5x must be negative because it is equal to k. So x square negative 5x must be less than 0. Now we can factor x out from this expression. When I factor x out, then I'm getting x negative 5 inside the parenthesis less than 0. Okay, here we have an inequality. In this inequality, we have to find the integer values. I mean, the number of integer values we have for x. Okay, initially I assume this inequality as an equation, that is let x times x negative 5 equals to 0. Okay, here the product of two terms equals to 0. So either the first one has to be 0 or the second one has to be 0. Let me write it. So when the first one is 0, we get the x equals to 0. When the second one is 0, we get x equals to 5. That is, when we add 5 to both sides, this negative 5, positive 5 will cancel out. I'm getting x equals to 5. Okay, now what I'm going to do is I'm going to plot these two values of x on the number line. So here we have 0, here we have 5. On the right side extreme we have positive infinity, and the left side extreme we have negative infinity. So we can split up the real number line into three parts using the two values of x, 0 and 5. So the first interval is a negative infinity comma 0, the second one is 0 comma 5, and the third one is a 5 comma positive infinity. Now I have to verify each of these three intervals with this inequality over here. Okay, now let me take the first interval. That is, I'm going to take a random value between negative infinity and 0. Let me take negative 1 and let me plug in this negative 1 for x. So here in this inequality, then I'm getting negative 1 times. When I plug in x equals to negative 1 over here, I'm getting negative 1, negative 5. I'm getting negative 6 less than 0. When I multiply negative 1 and negative 6, I'm getting a positive 6 less than 0. Actually, it is false because a positive value cannot be less than 0. So the value which I took in the first interval, that is between negative infinity and 0, does not satisfy this inequality. So this interval does not work with the inequality. We can reject this one. Okay, now let me consider the second interval, that is 0 comma 5. Let me consider a random value between 0 and 5. Let me take 1 and let me plug in 1 for x over here. Then I'm getting 1 times. So when I plug in x equals 1 over here, I'm getting negative 4 less than 0. 1 times negative 4 is negative 4 less than 0. Actually, it is true because a negative value is less than 0. So the random value I took in the second interval 0 comma 5 works with this inequality. So this interval satisfies the inequality we have over here. Okay, now let me take a random value, the third interval, that is, let me take a random value between 5 and positive infinity, that is 6. When I plug in x equals to 6, then I'm getting 6 over here. 6 negative 5 is just 1. So clearly it's a positive value less than 0. It's not true, it's false. So the third interval does not satisfy this inequality. We can reject the third interval. So only the middle interval, that is 0 comma 5, satisfies this inequality. And also the boundary values of the middle interval cannot be considered because when you take x equals to 0 over here, what will happen? When I take x equals to 0, 0 multiplied by everything will become 0. We'll be getting the result 0 less than 0. Actually, it is false. 0 and 0 are equal, but we are getting a result 0 less than 0 when I take the boundary value that is on the left side. So, and also when I consider the right side boundary value 5 over here, what will happen? So here when I plug in x equals to 5, 5 negative 5 will become 0. 0 multiplied by this stuff will become 0. Again, we get a false statement. That is 0 less than 0 will not work. So the boundary value 0 and 5 will not work with this inequality. Only the values we have between 0 and 5 in this interval will work with this inequality. So, and also we have to consider only the integer values between 0 and 5. Because according to the question, we have to find the number of integer values of x for which the value of k is negative. So between 0 and 5, how many integer values are there? So we can write 1, 2, 3, 4. So there are 4 integer values between 0 and 5. So therefore, there are 4 integer values we have for x, so that the number k is negative, and we find the 4 in answer choice C. The correct answer choice for this question is C.